Hello everyone, my name is Kexin. I'm currently a PhD candidate in the University of Alberta, and it's an honor to present our research about developing a digital twin-based framework for construction fire hazard recognition training. This work is collaborated with Mohamed Sabek, Dr. Kexin Liu, Dr. Kinateder, and Professor Vicente Gonzalez. I'll briefly introduce the background, the current practical challenges and research gaps, and followed by the research method and the system architecture we developed, and a short conclusion. So as we all know, safety is a big challenge in construction industry. We call the Factor 4, like fall from height, electrocutions. That's the most frequent accidents that causes thousands of injuries and deaths. However, there are also accidents like fire hazards. They are not that frequent, but they can also cause serious consequences. According to the data from National Fire Protection Association, construction fire causes 62 injuries, 5 deaths, 376 million property damages, and apparently this will cause project delay. So this is an issue that we need to pay attention to. When we're talking about hazards, the first and one of the most important steps is to identify the hazards. However, in the practical practice, hazards on construction sites is really hard to identify because we know it's dynamic, it's unpredictable. So as you can see in the figure, compared to other high-risk projects, construction sites only have around 16.6% of hazards have been identified. And current training methods, including online training, use the 2D slides and also quiz and the toolbox meetings. They are low cost, easy to deploy. However, they are for to engage workers, they overlook individual needs, and they didn't considering the dynamic nature of construction sites. So to address these practical challenges, current research, they provide valuable insights about how to develop a personalized training for the construction hazard recognition. However, up to date, there's still a lack of system that considering the dynamic nature of construction sites. And also, if you take a look at the second column, you can see most of the research, they consider like various type of hazards. They consider all the hazards in one study, and there are a few research that consider specific hazards like fall hazards. However, according to research, different hazards they require different cognitive requirements. So it's important to separate the different hazards as a consideration. And there's a lack of research about the training system specifically for construction fire hazards. So based on these two gaps, we developed a digital twin-based framework to integrating the dynamic nature, and also we're considering the fire hazard nature in our framework. To develop this framework, we're using a 5-step method in system architecture development. So first, we capture the needs. And then, based on the needs, we define the system objectives and those corresponding functions. And we analyze the interactions between different functions, and finally, we develop the system architecture. So in our system, we have 4 objectives corresponding with 4 functions. For example, our objective 1 is to provide training that can reflect site conditions, which requires our system should be enabled to capture real construction site environments. And I'll introduce the following other 3 functions in a moment. So here is our overall system architectures. And as we mentioned, our first step is function 1, capture real construction site environments. And here we introduce 360 cameras because it's easier to deploy, it's low cost, and it's fast. So by using the 360 cameras, we can take 360 videos like this. So I was wearing a helmet, and I took this around December, so you can see it's still covered by snow. And after the videos, we can deal with converting into 2D images, and we introduce a Gaussian Splatting method here. It's a recent method developed in computer science, and they can convert the 360 videos into 3D models. And I use a software here called Postshot. They integrated the Gaussian splitting method and including the training and also visualization process. And I also referred a paper here. They discussed the photogrammetry method and the Gaussian splitting methods. They compared the duration of generating 3D models and the accuracy of the 3D models. So this is one pipeline. And another way is we can just use 360 images. This is simpler and let's deal with the data. But both of the data can be imported into game engines like Unity 3D. This is a place where we can deal with the fire hazard tagging. So we require the inputs from expert panels and stakeholders because currently there is barely data about the fire hazards. By doing so, we can start tagging the fire hazards, label the different hazards, and provide instructions. By doing so, we can create an augmented virtual reality. Once we have the augmented virtual reality, we can enter the user-centered training. So first, we will provide a pre-training assessment. This is to establish a baseline. So we have two aspects we want to evaluate. First is situational awareness, and second is hazard recognition performance. And currently, there's a lot of research using eye tracking to evaluate SA because it's more objective. As you can see in the figure, we can see where the workers look at and where they didn't look at. And for the HRP, we basically evaluate how many hazards you identified correctly and how long it took to analyze these hazards. And by doing so, we can establish the training file and develop personalized training strategies. And then we will go to the training sessions. For example, this is a simple demo for a 360 images. And people can just wear a headset, and in these 360 images, we provide instructions like what's this hazard, and what's the risk level, and what's the instructions. You as a worker or as a manager, what do you need to do if you encounter this hazard? By doing so, we will need to do a post-training assessment, which is to evaluate if we achieve the learning outcomes. If not, we need to do a reinforcement training, and if it is, we still have one more question need to answer, which is, do we achieve a process checkpoint? Why we need to answer this question? Because as we all know, construction sites will have different phases. And here I only list 3 main phases like foundation, structure, and finishing. And we know they all involve different activities, equipment, materials, which can introduce different fire hazards. And for the training, the most important is it should be context specific. So we ask these questions. If we have significant changes on the construction sites, we need to update our training content. We need to do the data collection, processing, and integration and training again. And finally, we also want to provide historical data for continuous improvement. So we already got data from the previous stage, like the video, images, is available data for future use, and also identify the hazards. We can establish a fire hazard library. As you can see in the right figure, there are a lot of different types of fire hazards. And also the training scenarios established in Unity or other game engines can be stored for future use. So basically, we developed a DT-based framework specifically for constructing fire hazards, and we introduced a workflow, including the 360 camera and also Gaussian splitting to generate augmented virtual reality. And also, you can see our framework is modular designed, so we do not need to apply it at once. We can apply it gradually. And also, our research has some certain limits because for now, we got the system requirements from the literature. In the future, stakeholder inputs will need to refine our system requirements. And also for the training part, we will need to do real-world testings. Thank you for listening. Kexin, I'm supervised by Professor Vicente Gonzalez. If you have any questions, I'm happy to take care, or you can contact me. Thank you.